Hello class, welcome back to AP Computer Science Principles. I am Mr. Cunningham, and today we're going to talk a little bit more about binary, specifically how to change numbers from base 10 into binary. I'm going to provide you two different, both equally valid methods to do this. Let's go ahead and get started. For our first example, we are going to figure out what this number 18 is if we represent it in binary. Now, just like we did in the past video, we are going to start by setting down some placeholders and figure out what the value of each placeholder is. So the rightmost placeholder, as usual, is worth 1. And then, as you can remember from last video, every move to the left doubles the value. So the second place is worth 2, then 4, then 8, then 16. Now, I know that I can stop now. Can you see why? Well, if I was going to make another place value, that would be worth 16 times 2 is 32. But I don't need a place value of 32 in order to make 18. 32 is too large of a number to be useful in this particular situation. So I'm going to stop with the place value that is as close to the number I'm trying to make as possible without going over. And now it's just a puzzle. What combination of these numbers, when added together, make 18? Well, I know that 18 is 16 plus 2. 16 and 2 is 18. I put zeros in all the rest. 18 expressed in binary is 10010. Let's try another one. So for our second example, we are going to take the number 50 and put it into binary. Now, as you can see, I already set out my place values up to the number I'm looking for. Yeah, 32 is the highest bit that I'm going to need because the next one would be 64, which is more than I need. So now I've got 32, 16, 8, 4, 2, and 1. I'm trying to make 50. Now the puzzle is a little bit more complicated, but not that much more complicated. Let's see. To make 50, 32 and 16 makes 48, and 2 makes 50. Yeah? Double check me on that. 32 plus 16 plus 2 is 50, and we can fill in the rest with zeros. The number 50 in decimal translates to 110010. So that is one method that you can use to take a number that is in base 10 and put it into binary. It's not the only way, but it's the way that I happen to favor personally. The next method I'm going to show you is more of a shortcut. It's more of an algorithm, there's another word that we're going to be learning about later, than it is an understanding of the numbers. If this was a math class, I would be hesitant to show you this shortcut so early on, but because this is a computer science class, I have no problem with you either memorizing an algorithm or taking it down in your notes. Okay, so this shortcut involves dividing with remainders. So that's something you may have not done in quite some time, but I'm sure you'll pick it up again very quickly. The idea is, take your number, in this case 24, you're going to divide it by 2 and note the remainder. So 24 divided by 2, well, that is 12 with a remainder of 0, right? It does divide out evenly. There is no remainder. 12 times 2 is 24. Then do the same thing again. 12 divided by 2 is 6, also with a remainder of 0. Step 3, 6 divided by 2 is 3, also with a remainder of 0. Everything has been dividing out evenly so far. But here's the trick. 3 divided by 2 is 1, with a remainder of 1. And then finally, 1 divided by 2 is 0 with a remainder of 1. Okay, move that up a little bit to make sure that it's visible. Now, again, the process was very simple, right? We took our original number 24 and we kept dividing it by 2 over and over and over again until we got a quotient of 0 and we noted down all of the remainders. Now the easy part. We've already got our number. This is our binary number. We just have to write it from bottom to top. So 24 in binary is 11000. Yeah? Let's double check that just to make sure. Anytime you use a new technique, you should always check it against the old techniques to make sure that it actually works. Boom, 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 boom. 1, 2, 4, 8, and 16. Yeah? The only 2 places where we actually have ones are 16 and 8. 16, 17, 18, 19, 20, 21, 22, 23, 24. So yes, indeed, this is the binary representation of the number 24. Now, I am going to do more examples of this in a later video when I get to it on Khan Academy, but for now, please feel free to leave your questions in the comments. I will do my best to respond to all of them. Thank you very much for watching, and I'll see you next time.